Hello, welcome to reInvent. My name is Pınar Yılmaz. I'm a senior software engineer in AWS Deep Engine team. Today I'm going to be talking about Amazon SageMaker Clarify and how this tool helps you understand machine learning predictions and biases. Today we're going to start off by defining what bias and explainability mean in machine learning, and then we're going to give an overview of SageMaker Clarify. And then we're going to talk about how it's used at Prudential, and we're going to finish off with a demo. Bias can be broadly defined as imbalances in the accuracy of predictions across different groups in machine learning. And the main reasons that we would want to do this throughout our machine learning lifecycle is in threefold. First off, in the beginning of the machine learning journey, we will start by the data science phase of the project. And this is when we collect the data, we clean up the data, we prepare the data and get it ready for training and try different algorithms and machine learning models to understand the business use case and how it unfolds. And during this time, it's important to understand if there are inherent or embedded biases in the data set or the model itself. In the next phase, when we're operationalizing these machine learning models, we would also want to understand how to provide these explanations about the model behavior to different stakeholders. These could be internal or external. Internal could be people such as loan officers, customer service representatives, or forecasting teams. And sometimes for external parties, it could be even the end users or the customers of a particular business. The third phase is regulatory purposes. Today, the world governments are coming up with new laws and regulations around the algorithm behavior and right to explanations by citizens, and understanding why the machine learning made a particular prediction and also if the model was influenced by potential bias will help you comply with local laws and regulations. You must have seen headlines in the news lately where an algorithm was found to behave in undesirable ways, causing problems and making the headlines. And this is something we would like to avoid, and we would like to intervene as early in the machine learning cycle as possible. When you think about how to implement explainability in practice, the first hurdle you're going to run into is what it means to be accurate and interpretable at the same time. You will quickly find out that there's actually a trade-off. When you use simple models that are easy to understand and interpret by humans, you may not get the accuracy desired, such as rule-based learning or linear regression, where you can just look at the rules or the coefficients, and in the case of decision trees, just the tree structure. But this may not give you the best predictions with the high accuracy that you would want. Then when you go for more complex models, such as deep learning, which may have millions and even billions of parameters, then the model becomes essentially a closed box for humans to understand and interpret. So what do? The research area is ripe with many different techniques and algorithms to provide explanations. And these techniques range from perturbations-based, ablation or permutation-based, gradient-based algorithms using neuron activations and things like sensitivity analysis, saliency masks, rule extraction. All of these techniques are available in the wild today. But how do you pick the right method or algorithm for your use case? And once you do, how do you get these explanations in the form appropriate for your use case? And how do you make sure that they are consumable by the internal or external stakeholders, such as are they numerical, textual, or visual, and how to represent them? Let's talk about how DFL-Bundesliga uses explainability in practice. Bundesliga match facts are powered by AWS, and it provides a more engaging fan experience during soccer matches for Bundesliga fans. X-Goals, which is short for expected goal statistics, uses a machine learning model trained on Amazon SageMaker. and it allows to determine real-time goal scoring chances based on 16 different factors. With explainability, with Amazon SageMaker Clarify, Bundesliga can explain what some of the key underlying components are to determine what led the machine learning model to predict a certain X goals value. And knowing the respective feature attributions and the outcomes helps to explain how to debug the model, increase confidence in the algorithm, and fans can evaluate the goal scoring chances of Bundesliga players from any position in the field. In SageMaker Clarify, what we're offering is a collection of APIs and core libraries, and these tools are broadly integrated into SageMaker. We offer a first-party container to be used as SageMaker processing jobs, which is framework and model agnostic, and our core libraries are used for bias detection, mitigation, and explainability, which is optimized to run on AWS. You can find these tools and features spread throughout different SageMaker components such as Studio, Data Wrangler, Debugger, Experiments, Model Monitor, and Pipelines, and more to come. If you consider the machine learning lifecycle, as we were talking earlier, we start by collecting and preparing data, and SageMaker Data Wrangler will allow you to run a bias report to understand the bias metrics in your dataset before you even start training. Next, we're going to train and tune the model using SageMaker training, autopilot, or hyperparameter tuning. And at the end, we will have a potential viable model, and we can use our processing job with our container, first-party container, to understand the bias metrics and explainability metrics, given the combination of the dataset and the model. Next step is to deploy this model in production. When we look at deployed model, we would also want to monitor the bias metrics and explainability metrics continuously and make sure that these metrics do not vary wildly, indicating that the real-world conditions have changed and now maybe it's time to collect more data or retrain again. So to recap, SageMaker features can be used during the data preparation to explain the trained models and detect the bias inherent in the model and the dataset combination, explain the inferences made by these by these models, and also monitor this model throughout the life cycle of the model itself. Next, I'd like to invite Michael Sun to talk about how they use SageMaker Clarify at Prudential.
Thank you, Pinar. That was great. And hello, everybody. My name is Michael Sun. I'm a Vice President of Data Science of Prudential Financials. So today, I'm going to tell you something about Prudential and the current state of AI/ML practice in our company, as also why we think SageMaker Clarify has been such a great tool for us. So Prudential is one of the largest financial companies in the world. We have tens of millions of customers in the United States, as well as across over 40 countries. The company was created more than 160 years ago. And over the last 100 years, we have a deep bond and trust with tens of millions of our customers, providing their financial wellness, protection needs for themselves and their families, also the investment opportunities. When I talk to a future data scientist about the current state of AI/ML at Prudential, as also why they should be part of this effort, I would say that for other companies, understanding the future, predicting the future in terms of both risk and opportunities might be something nice to do. Maybe something sort of a current fad, if you wish. But understanding future risk is part of our DNA, and it has been for the last 160 years, as I said. So that is why the sort of AI/ML is so important for an insurer such as Prudential Financials. So as we have built the practice and capability, we have focused on all manners and aspects of how we can serve our customers better, which including predicting mortality and morbidity risks, right? providing customer experience, the best customer experience we can for our customers. Fraud detection, which is another key concern for insurers as a present and danger all of us are facing. So this is the future of Prudential AI ML, and is how it's being practiced. It's a huge part of our DNA, and we welcome everybody to take a look at us and potentially join our efforts. The need of explainability is particularly important for insurtech company, as we are practicing at Prudential. So when we talk about AI explainability, what does that mean to us? There are several aspects. We want to be able to tell our regulators and other stakeholders how our data is collected, right? What features are generated, how their weights and biases are assigned, and what algorithms were used, how the data are validated, or results are finally validated. All the aspects are important. As I say, we need to explain that result to our external regulators as well internal stakeholders. Last, but definitely not the least, is our customers. As I started by saying that Prudential built all this amazing product and service over 100 years, but underpinning all those product service is that deep bond and trust we have built all those years. And an open and honest dialogue and communication is the basis of every trusting relationship. So we will not squander that trust by producing something which we cannot be having an open and honest dialogue with a customer, explain to them why certain underwriting practice is done the way it is done by AI, or how the pricing structure to come about. So explainability to us means trust, and that is something we hold secret and will not to sacrifice or anything else. As we try to explain AI ML message to our customers, we're facing similar challenges as a lot of you probably have already faced. Right? There are multiple approaches for a given problem. So as we try to explain those algorithms, we often have to sort of juxtapose and be switching from one end to the other. For example, from logistic regression all the way to deep learning and to tree type of algorithm and back. So those kind of diversity and the array of challenges faced about multiple algorithms pose a challenge for us to explain our results. On top of that, our data set tends to be large. As I said, we have tens of millions of customers, and those customers have so many touch points with us. So the data set and computation needs to explain the algorithms is a huge challenge in and by itself. So which comes SageMaker Clarify. As Pilar said in her opening remarks, and the team at Amazon AWS, when they set out to tackle these problems, they had those customer needs, customer business problem in mind. And for us, particularly these two areas, the question I raised, we found very, very encouraging and promising results working with AWS teams. First, the Clarify offer multiple choices, right? So we can combine easily. So that gives us the flexibility. But also the team has done an amazing job in optimizing, parallelizing algorithms. So we found that we can get the same results in a fraction of time what we used to take. So on both accounts, I say Clarify should be a tool you should consider when you are tackling an AI explainability problem. For the next steps, we are actively considering scaling the test by both including multiple new use cases as well as scale up the data set and multiple algorithms, so we can really test the boundary and how widely it can be incorporated into our sort of a data explainability repertoire. As we are building a future AI ML platform, model governance is a key topic as well. SageMaker Clarify is currently being actively considered as a part of our future governance. So every model for Prudential's AI ML platform will have this incorporated, and AI model explainability will be enhanced with this tool. Thanks everybody for listening, and back to Pinar.
Thank you, Michael. Next, we're going to see how these features are used in SageMaker Studio. First, we will start by showing you how to run a bias report in Data Wrangler. In Data Wrangler, the first step is to import a dataset, and we're going to import our dataset from an S3 bucket. In Data Wrangler, you can run transforms or analyses. Bias report is a form of analysis. So once we import a dataset, we're going to create a new analysis, and we're going to select bias report from the drop-down menu. Next, we're going to select the label, which is the target attribute in our dataset. And the next value that we would like to plug into this report is what constitutes a positive outcome for this use case. So this is a credit dataset, and the label good credit having a value of 1 means a positive outcome for this particular individual. Next, we're going to select the sensitive group from our dataset. In this dataset, we're going to select age as the sensitive group and indicate that value of 40, meaning 40 or above, is the sensitive group in this case. And we're going to compute the bias metrics for this sensitive group. We're going to select which bias metrics we want to compute. You can select all and see and click on the report to see the bias metrics. You can explore these values on the resulting report screen, and the drop-down menus will help you to pull some information about what this metric is, how it's computed, how to interpret and understand the value, and what to do about it. And also links to further reading resources are available right there. We can also look at the bias metrics as a table. And then once we create this report, we can save it and as part of our data flow and use it as a record of our dataset. Next, we're going to look at how to run a processing job to get the bias metrics and explainability metrics for a model and dataset. For this, we're going to use a notebook that we're going to run inside of SageMaker Studio. So in this notebook, we have already trained and created a model, and we're going to use this model to run a processing job, and we're going to create a processor using the SageMaker Python SDK. For this processor, we're going to provide 2 inputs: analysis configuration file, which is a JSON file that contains the various parameters for the algorithms, and the dataset itself. And in the output, we're going to indicate where we would like the job results to go. Once we run this job, we're going to get a JSON report with all the metrics computed from inside the job. This includes the local explanations, global explanations, pre-training and post-training metrics. We can download this file and inspect and consume it right within the notebook. When we explore these metrics, we find that the class imbalance is indicated as a high value here, and we would like to confirm that by running a quick experiment on the dataset and plot the values in a chart, which confirms the class imbalance indicated by this metric. Next, we're going to explore the feature importance, and we're going to use the open source SHAP library to plot these values, which have already been computed inside the processing job. This is for visualization only. All the computation has already happened inside the processing job, and we have access to the global and the local SHAP values at this time. We can also look at these same values and explore the report visually inside SageMaker Studio. For this, we're going to locate our processing job in experiments as a trial component. And when we describe this trial component, a new tab opens up where we can see all the bias metrics and the feature attributions together in the same tab. The same drop-down menus that we were looking at earlier in Data Wrangler are also available here. And now we have more metrics because now we have access to pre-training as well as post-training metrics. Similarly, we have the metrics as a table or the drop-down menus. And we can also explore different facets here. Facet being a sensitive group here as indicated by our configuration file, and see different bias metrics computed for each of these groups. Next, we're going to look at how this is used in Model Monitor. So in Model Monitor, the first step you would want to do is to deploy your endpoint and enable data capture on it. Next, we will have created a model monitoring schedule with a job definition that includes that we would like to collect bias and explainability metrics. And we have already done that here. And next, we're going to explore how these are presented in the endpoint section of SageMaker Studio and how we can visualize and understand these metrics. So first, we locate our endpoint. And then when we look at the model insights and the bias report tabs here, we can see that the jobs are running on the schedule that we indicated. And we can visualize different metrics, compare from run to run, and also understand how the feature attributions change over time by looking at individual features and see how they change in ranking over time. So what we would like to see here is that the features don't change their attributions over time in big increments, and they remain relatively stable over time, meaning that the assumptions and the learnings in our data set and model are still valid. So in here, what we're looking at right now is the feature attribution for one feature, and see how they changes from one run to the next throughout the model monitoring schedule on the live endpoint. Next, we're looking at the bias metrics here. And in here, we can also see the same bias metrics that we were looking at earlier and how they are computed from one run to the next. And we can see if the bias metrics cross thresholds, that would indicate that the model is behaving in a more biased way than we had initially set it up to be. And this might be a sign that the model is behaving in a different way than we would like it to be. And maybe, again, it's time to collect more data and retrain. We can also plot the different metrics over time and use different intervals and different combinations of comparisons. This concludes our demo. So to recap, Amazon SageMaker Clarify will help you detect bias during data preparation, detect bias in your trained model, detect drift in bias and explainability for the model behavior. And you can use SageMaker Clarify to provide reports to internal and external stakeholders, explain individual predictions, and explain overall model behavior. So thank you for watching, and thank you, Michael, for joining us here today at reInvent.